Right. So I'm Adam, and feel free to grab me when you see me or when you don't see me and speak with me about all these things and all the other things. So, as Alish mentioned, last year I wrote a list of things that I'd like to do, and I know some other people want to do. I'll give you a few seconds to read that. Okay, now let's see a show of hands. Who has wanted to do at least one of these things at some point? Okay. Yeah, well, there's a couple of people who have not wanted to do this. Okay, so this is not going to be anything exciting, but obviously something useful. And this is, has been the state of the art until now, and I think we can all agree that that is not art. And we had some proposed design last year, and now we have an implementation, and it allows you to write this instead, which is still not art, but sure is nicer. And as predicted as well, last year, the performance is going to be a whole lot better. So let's just compare that, and we get a result that looks like this. You see the star in the corner, that means the result is different, and that's to be expected, because I wasn't trying to give, with the state-of-the-art expression doesn't try to give any kind of useful result. But with quad VSET, we're returning a reference to the namespace or namespaces that we are changing, which is a more useful result. So it's all good. Then we want to also get values. And again, state of the art is no good, and the replacement is yes good, and it runs fast as well, so all good. A little bit more of the details of this. We can give names with their values in pairs. We can set them in the current namespace, we can set them in a target namespace, probably the more usual thing to do. We get a shy reference back, or we can also set a single variable, just have to be an array of name and variables, and often you have list of names separately and all the values you want to set them to, we can do that. And the same when we want to get values, then we can have name value and pairs, and we can specify a value that we want to return if we can't find an actual value, and we don't need to. If we want an error, then that's fine, and we can get a single value, of course, and we can also want all the names that are in a namespace, and we can get them as list of names and their values as well. The left argument to all these functions are either references, either one or multiple, or names, or one name, or mixture, anything goes. Simple rule, if you specify multiple namespaces, we'll just do it in every one of them. And if we are getting values, the result as well, when we get references to namespaces that we changed, is whatever structure you gave. Extending quad NS in exactly the same manner. Quad NS has been able so far to take a single namespace as right argument. Maybe not many people know this, but it will attempt its best at creating a new namespace that contains the same as the old namespace, but otherwise disconnected. So we can give it multiple namespaces, and it will make a new namespace that contains the same as the old namespaces in plural. It can either be a new namespace, or you can do it to an existing namespace. And of course, you can do that now, not just with the name of a namespace, which was the case until now, but you can also do it with a reference to the namespace, so you don't have to have a name for it. And now, that list of things that we wanted to do. So, the plain functionality, we want to just get some values from some names. We can use a vector, we can use a matrix of names, anything works. Same thing the other way, we can set them. We can use name-value pairs. We can use pairs of names and values. We've had a couple of different ways to take care of an optional left argument until now, and none of it was very nice. It's maybe not the most concise it could be, but at least it's consistent and easy to follow what's happening here. If we don't have a value for it, we fall back to a default value, and then we can assign that. Although often you just want to use the left argument, and if it's not there, use some other value, and then it's even simpler. Something we've wanted to do in various utilities a lot is that the user supplies a namespace of options, but the user might not have specified every option, so we want to fall back to some values that we have collected in a different namespace. Very easy. Here are the roles. We can take any number of namespaces. So that means you could have, say, a set of global settings, and then you have a set of some tool-specific settings, and then you have some user settings, and then you have some session settings, and then you have some customizations for this very run. And you just list them in the order from the most general to the most specific, and Quadernes will just merge it all so that the most specific value is the one that's the effective value. Something that's very common where you get data from outside. Let's say that we have a family, and there can be various parameters for this family, including how old all the children are. And maybe it hasn't been specified how old the children are, so we'll just get an empty vector back. And if you want to do that for multiple families, well, you replace the reference to one family with reference to multiple families. And we can do different fallback values for each thing that we are querying. And of course, that also works for multiple families. Let's say we want to build a namespace. So we have to create a new namespace, and then we can set the values and to their corresponding names. Or we can use name value pairs if you want to do that, and use that instead. And then of course, with the array notation, we don't have to have that a little bit ungainly Quadernes there on the left. We can just create a new namespace cleanly. I've gotten the question, does this work on objects? Yes, it works on objects. Same thing. Let's try to play with our data a little bit. So we import some data using quad_csv, and notice the one there at the very end that tells quad_csv that I want the first line from this file to be a header. So these are all the column names, and we want those separately. That gives us back a pair of the actual data, a matrix, and a vector of names. But we want each column separately, so we can split it. And we want our list of names. And we can set those values in a new namespace. And now we have a namespace that represents the table. And we could query this namespace. We can use a nice notation for that. And we're also working on making it even more seamless to use with things like quad_csv. So you can actually already tell quad_csv that you want the so-called inverted table. That means you want a vector of columns, where every column is represented by an element, normally a vector or matrix, in the result, in the table. So that makes it even easier. We don't have to split it ourselves. It just comes for free. And right now we're working on the exact design is undecided, but something that will allow you to even tell it to give you a matrix back of header names, so that we don't have to do that mix ourselves, make it even easier. That means you can easily write it inline as well. Sometimes the header names are not valid APL names, and we can borrow them from the JSON interface. We call JSON. There's a special companion IBeam that allows us to translate between any character vector and an APL name, a one-to-one translation. So if we want to be able to store as a proper APL namespace something that has invalid names in it, then we can translate that. Then maybe we'll make some setting or some automatic thing that translates the names. We can figure that out. We can also do the opposite thing. We start off with a namespace, and we want to export it as a table or view it as a table. So we can now ask for all the names and all the values, and then we can just write it out to a CSV file. That's easy. We can get name value pairs, and then we can transpose them around, so we get all the headers, all the data, and then we can use APL to piece together a nice displayable table. You can imagine what this would look like. headers at the top, columns going down below them. And if we have names that have been mangled because that was the only way to fit them into APL, then we can translate them back to a nice displayable form when we create our CSV file, which isn't restricted to APL names, and the same thing for display output. Here's an example with, we get some JSON data in. Normally you wouldn't have it as a literal, but you would get it from some online source, something like that. But we get it in as a namespace on the APL side. That means we can get the names, get the values, and then we can piece together a table, and all we need to do then is transpose it, and we have a nice displayable table straight from JSON. If you have an application that has some flag you can set somewhere, but it's not always there, say a debug flag, then you get a value error if you just try to query the debug flag, global variable, for example. But we can fall back to another value like that. And it tends to get used in things like disabling trapping in various ways, or setting the trapping. And that's not very exciting, but very useful, in my opinion. That's really all there is. Right, thank you so much.